Hello, Mr. Akim.
Hello, good evening. Can you hear me?
Yeah, I can hear you. So
Okay.
I'm making you co-host now. And I'm
Okay.
also our first person who came in, Shehu Muhammad Salih, also our co-host, so that in case anything happens, we'll still make God as co-host anyway. So please let's quickly test run so that we would know that everything is intact before we start the program. Can you hear me, Abdul Hakim?
Yes, I can hear you.
I said let's test run and see before we
That's what I want to do now. So can you see my slide now?
yes, I can see your slide.
Okay.
I can see.
Okay, let me put it on. So is it much better now?
Yeah, I think it's very okay now. The only thing we need now is to know the strength of your network. I think that is
my network. I think is very good. I'm using Airtel. So
is Airtel good in your area? Because Airtel might be good.
It is.
All right, that's good. All right, thank you very much.
Okay, thank you.
All right.
Okay.
So we can also share the invite to people around us to join. Mr. Lakim, if it's possible for you, you can share the link on the broadcast on the group so that those that are in already will send invite to people to join.
Okay, no problem. I'll do that.
All right, thank you. Yeah. So it is 5 o'clock. Thank you all for making it up to this moment. It's 500 thoughts, and we have 10 participants already. Like you used to say, we don't actually focus on the number. We focus more on the quality of what we are delivering, because it will always be available. Because all our sections will always be available for future reference. So whoever maybe due to some reasons could not meet up with our section, the recorded version will always be available on our YouTube channel. We appreciate everybody's presence. We appreciate you for making it up to us today on another episode of Statement Waliola, where we discuss a lot of safety enlightenment topics. And today we are having one of our safety professionals with us who will be enlightening us, who will be discussing with us, who will be training us on a very important aspect of safety. And I appreciate your presence. We appreciate the presence of Mr. Shehu Muhammad, who was the first person to join, followed by Emily Tilton, followed by, I think, Mr. Tianki Ku, I don't know the country. Then Engineer Anif York, Mr. Abdulazim, Mr. Taiwo, Aminu Shuaib, and Mr. Emmanuel. Thank you all for making it up. Please let's exercise patience. It is just 5 o'clock. Once it's 5:05 or 5:10, we shall start the training properly. Thank you all for your patience.
Thank you, Mr. Waliu.
Thank you, Mr. Waliu.
Thank you all. Thank you. Thank you all for your patience. Thank you for having us, for taking your time, your energy to join us on today's episode of Safety Mental. Where we're discussing about electrical safety. In so many, in recent times, we've had a lot of stories concerning, we've watched videos of people innocently getting electrocuted due to lack of knowledge and due to exposure to high risk hazard, electrical hazard, and it has led to death of so many. So we have decided today that we should talk about this very, very important topic. And we have with us not just a safety professional, but a safety professional in the area of electrical safety. It works in the electrical distribution. It works in the electrical industry, the power industry, and has gained so much knowledge and expertise, skill, competency level that is required to educate us on this very important topic. I tell people that this particular episode is not just for safety professionals alone. It's for safety professionals and non-safety professionals, and for everyone who lives in a residential area. And I don't think there's anyone who doesn't live in a residential area. We all have where we live, and we've had issues. We've had stories of due to poor electrical safety risk management that has been implemented maybe during the time of construction or during the time of management of buildings and the like, or even due to human error. People have become victims of electric shock. People have become victims of electrocution. People have become victims of serious electrical burns that leaves a permanent mark in their life. So how do we prevent this? How do we educate people? How do we enlighten people? Like we used to say, you can't give what you do not have. Even as safety professional, it is very eminent upon us that we continue to re-energize our knowledge. It's very eminent upon us, very compulsory that we continue to go for webinar series like this, that we keep reminding us of our core duties. And that is for safety professionals who are very skilled in the area of safety, not to talk of those who do not understand what safety really means. And that is why this particular episode is for every single person. So if you have people around you, you think that they need to understand this aspect, people you love around you, you can as well share them the invite so that everyone will benefit immensely from this. Yes, when it comes to electrical safety, it goes beyond just the electrical shock. We have electrical fires, we have electrical explosions, we have other occurrences, we have secondary accident that happens as a result of electricity being the primary cause or even being the secondary cause. So many things are going to be discussed about today. Just stay in touch, just keep in touch, just continue to listen to us, just continue to be patient with us while we start this episode. And we promise you that it is going to be very educating. If you haven't joined us on our social media, handles, most importantly, where we are currently live now, we are currently live on YouTube. As we are discussing now, it is also available on YouTube. So for those who can't register, or who can't join us for one reason or the other, they can just go to YouTube and watch us. Our YouTube handle is Safety Moment with Waliola. I think we will actually post the link to join us live. Our YouTube handle is Safety World Space TV, Safety World TV. So the Safety World is written together. You write the Safety World together and the TV separately. So TV, T and V together. So Safety World together, space TV. So that is our YouTube handle that you can tell people, invite people to join us live on YouTube and watch us from YouTube also. We'll also post the link now so that we'll also easily share the link, the YouTube link for people to join us. And if it is better for them, if it is easier for them to join on Zoom, definitely our Zoom is also available right now. We have a maximum of 100, so we still have a good number. We still have a good number. People can still join us live on YouTube. People can still join us on. Sorry. Sorry, I think I'm having. Please, can you signify if you can hear me, please?
I'm hearing you.
All right, thank you for that. I want to be sure that I'm not lost. Okay, yes. So thank you for that. Please kindly drop your hands. This is not the time to ask questions. Please kindly drop your hands, kindly lower your hands. Once it is 5:10, we'll kickstart our introduction to the training. We are already doing the introduction. We'll introduce our speaker for today and we'll kickstart immediately. So we'll keep, here is the link. I'm going to share the link with us now. So kindly type your name and where you are live from. When you are joining us from, kindly type to us where you are joining us from. You can watch on YouTube live. You can watch us live on YouTube. That is the link for YouTube. So kindly tell us where you are where you are joining us from. It is very important so that we'll know where our participants are from. You can see different names, funny names. You know, it's funny to us. Even our own names is funny to them also. So we have different culture, different backgrounds, different ethnicity, but we come together for one purpose. That is for the purpose of safety. This is Westin Musonda from Zambia. This is Westin Musonda from Zambia. Okay, someone said there's no sound. Please, if you can hear me, just type 11111. Let me know if you can hear me. Just type 1. Just type 1 if you can hear me, so that I will know if the issue is from me. 1, okay, people can hear me. 111, okay, that is good. It shows that the person should address the network from his place. Okay, we have Muhammad Hassan from Abu Dhabi. Thanks for joining us. Thanks for joining us. Yes, Engineer 18 from Nigeria, Mowe. We have from Port Harcourt.
Kindly asking for the link so that I can watch you on YouTube, please.
Yes, I will send the link to you now. Okay, I was typing. Yes, you will see the link on the chat session now. Yeah, that's the link. That is the link. Yeah, we have Eric from Accra, Ghana. That is beautiful. Engineer Shuai from Okorodu, Engineer Ola from Abuja. Yeah, that is the link. Taiwo Adekunle Olubenga from Lagos. Yes, Nigeria, Abuja, Ghana, Zambia, and the likes from Ogun State. Thank you all for joining. So it is 5:10 already, and we are going to introduce our speaker for today. I believe our speaker is right here with us, Mr. Hakeem Mukhtar. Yeah, I can see him. Mr. Hakeem Mukhtar is a vast health and safety professional with multiple years of experience in occupational health and safety, and also in power safety, electrical safety. He works with he works as a safety regional safety professional for Ibadan Electrical Distribution Company, which means that he's the right person for this job, because he's the frontliner when it comes to issues of accident that they've experienced and issues of safety practices that is going on there. So he can use that as a platform, as a background knowledge to educate us, even though he would not be mentioning anything that has to do with his organization, but because of this level of expertise, I will believe that it is well to do to carry us on this very important aspect of safety. We will advise that Mr. Nabil, I think you should check your network. Mr. Nabil Ahmad, please check your network. Maybe you check your setting. Maybe that's where the issue is coming from. So I invite on the podium, with all respect and humility, Mr. Hakeem Mukhtar. Thank you, sir. Over to you.
Wow, good evening to everyone. Good evening, my leaders on the call. As I was being introduced, I'm still a young emerging safety professional, although currently in the electrical sector, which I work with Ibadan Electricity Distribution Company as a regional safety officer. And the topic I was given to discuss about today is on electrical safety. And the reason why we are bringing up this topic today is majorly because of some incidents that have happened, generally both here in Nigeria and outside Nigeria. Because I know vividly well that many of us have been a victim in one way or the other, or seen a story in one way or the other of incidents that has been happening here in the electrical sector. So just to boycott, and why is this topic being discussed? But before I move on, please, can anybody see my slide?
Yeah, I can see your slide, sir.
Okay. So just before I
Yes,
move,
confirm. I can see it.
yeah, thank you so much, Sas. So just before I move on, I want us all to know what is the history or what is the background behind this training, and why are we talking about electrical safety and protection? Generally, when we are talking about electrical safety and protection, it's just an aspect of safety, because we all know that safety is very broad, as we know that it is a multidisciplinary course, and which we have different sectors. We have the mental safety, we have the construction safety, the electrical safety, we have the oil and gas safety, and so on and so forth, just to mention a few. But the reason why we are talking about this electrical safety and protection is because of incidents that have happened, which I mentioned earlier. And I think I once heard of an accident that happened in one of the distribution sectors here in Nigeria, whereby there was a power surge, and eventually, due to ethnic system, due to poor ethnic system in the house, it ended up resulting to people dying. So in a nutshell, during the course of training, I'm going to make sure I try as much as possible to domesticate it with a lot of examples. So some of the examples might be imaginary examples, and some of them might be real examples that I've heard of in any sector. I think I've had in the power sector or TCN or the GENCO. So if I'm giving an example, please, for disclaimer, don't think it is an accident that happened in my current place of work. For disclaimer, don't think it is an accident that happened in my current place of what? Current place of work. So I'm just trying to make it as much as interactive as possible. And I'm just trying to make it as, how will I call it? As a, to make it to domesticate the training, because I know most of us on this training, aside that we have been a safety professional, we also have others that are not safety professionals on this call. So, and this is just more or less like a way of doing public sensitization on electrical hazard and safety. And this is also as a way of trying to make us know about the public sensitization of right of way, about electrical home safety, and also generally when we talk about ethnic system. So that's what we're just trying to talk about generally. So, but nevertheless, please, any example being used here once again is not related to what is happening in my place of work. It is something that is happening across power sectors in the world, which I think I will try as much as possible to domesticate. So as I've earlier said, I said, what is the reason for this training that we are talking about? Generally, even despite we have safety officers in our midst, as we all know, not all safety officers are being equipped with the knowledge of electrical safety. And this training generally is being focused not on safety officers, as I've said earlier, but also being focused on we that we call both vulnerable staff and non-vulnerable staff. Look at that word with emphasis: vulnerable staff and non-vulnerable staff. So when we're talking about vulnerable staff, that is those people who are working in the power sector. That is, they are working in the day-to-day, their day-to-day activity involve them to work with electricity. It might be an electrician, like the which we have an organization, LECAN, that is the Licensed Electrical Contractor Association of Nigeria, the LECAN. It might be someone who is just working inside his house. Every one of us here are vulnerable. Every one of us here are vulnerable. Whether you're working as an electrician, whether you're not working as an electrician, we're all vulnerable. So far we deal with what? Electricity every day. Because as we know, after life, after water, the next most important thing in the world is light. That is why God also said, let there be light. So looking at it, if there is no light, I doubt two of us or all of us on this call will be here today to be communicating on electrical safety, because everywhere will be dark. There won't be means of us communicating, except probably we had to travel long distances to meet one another if there is no light. So looking at it, we generally are talking about the, sorry about that. Okay. So I'm going to my next slide. So before we move into electrical safety, because we know most people that are on this call, some are safety officers and some are not even safety personnel. So we'll quickly run us through the basic concept of what? Basic concept of safety. So when we talk about safety generally, what is safety? From the word HSC, I know most of us will have been hearing HSE, HSC. What is this HSC itself? The H stands for health, the S stands for safety, and the E stands for environment. So when we now talk about health, health generally can be defined as the complete state of what? Complete state of well-being. It can be physical well-being, mental well-being, social well-being, financial well-being. Because even though if you are very poor and you don't have fund or you are into any financial crisis, it means that you are what? You are not healthy. So health generally is just a what? A complete state of what? A complete state of well-being, whereby you are physically stable, mentally stable, emotionally stable, socially stable, financially stable, and so on and so forth. But when we now talk about safety, what is safety? Safety is just what? The freedom from danger. The freedom from what? From danger. That is the stage in which we are free from being harmed. That is what we call what? That is what we call safety. And when we call environment, we all know what environment is. Environment is just the surrounding where we find ourselves. That is, it can be our equipment. The working equipment you are working on can be your environment. The laptop you are working with can be your environment. The land, the water, the flora, the fauna, and human around us. We human and our interrelations that we do. Anything we human interrelate with, anything we human works with can be our environment. For instance, for those who are software programmers, their computer is their environment. For those who are electricians, the poles they are working with is their environment. So anything that you are what having interrelation with is what? Our environment. Now, looking at it, there is a note that I said earlier. I said safety is the freedom from what? Is the freedom from danger. So now we are going to what is hazard. As we all know, now let's look at this video. I think most of us know this person. That is Hazard, Michael. So, and as he's a footballer, as we all know. And we all know that whenever he gets close to a possession or he has one-on-one interception with a goal, it means that the goalkeeper or the goalpost will soon be armed, because he will surely try as much as possible to score, except probably the defenders in the goalpost are able to get it and end up delivering. So looking at it, the hazard I'm talking about here is not about this hazard I'm talking about. But the hazard I'm talking here is what? Anything that has the potential to cause harm or injury. Anything that has the potential to cause harm or injury. That is, anything that can make you get injured. Anything that can make you get injured. That is what we call what? Hazard. So please, can I ask a question? Can anyone unmute and tell me, is there any difference between hazard and danger? Is there any difference between hazard and danger? Can anyone please unmute and tell me if there's any difference between hazard and danger?
I will need to reconnect.
Hello? Mr. Wali, please help me check if anyone is raising up his hand.
Yeah, hello.
Hello, I can hear you, sir. Please kindly introduce yourself, sir.
Yeah, my name is Eric Opong, speaking from Accra, Ghana.
Okay, you're welcome, sir. Mr. Eric Opong.
Yeah, thank you, sir. To me, I think they are the same, just that it's a different way, because if you see something danger, it's warning you that it can cause a harm or injury to you. And hazard, as you have defined, is also something that can cause a harm or injury to you. So they are almost the same thing, just that the words that are used differently. Thank you.
So if I will get Mr. Eric is saying hazard and danger is the same, right?
Yes.
Mr. Eric, am I right?
Yes,
So
please.
Wali,
Yes, please.
I think some people are raising up their hand. Please, can you help me? Okay.
Hello.
Okay, I can hear you. So
Okay, sir.
Okay, so is there any difference between hazard and danger?
Yes, sir.
Please kindly introduce yourself.
Okay, my name is Dennis February.
Okay, sir.
I'm speaking from Lagos here in Nigeria.
Okay, sir. You're welcome, sir.
Yeah, thank you very much, sir. From my own end, I think the talking about danger. Danger is already a discover is something already is an assessed already assessed something like a risk that has been identified that can cause any injury if if maybe you attempt coming around or disobeying whatever rules across it. Meanwhile, a hazard, like he said, it just has that potential to cause a harm, but it could be around and you won't know it. So that's it.
Okay, so if I get you right, you said there is difference between hazard and danger, right? And
Yes, sir. Yes, sir.
the danger is just more or less like a characteristics. Abi now?
Yes, sir.
Okay, good. So can I get your name again once again, please?
I'm Dennis.
Okay,
Dennis.
Mr. Dennis. Okay, let's give another person a try. So before we now know if Mr. Dennis was correct or if it was Mr. Opong that is correct. So Madam Omolola, or what's his name? Omolola. I think some people are raising up their hand. Madam Omolola Ayodele or Mr. Omolola Ayodele. Please, can you unmute?
Okay, good evening.
Good evening.
My name is Lola from
Okay,
Lagos.
Okay, you are welcome.
Okay, thank you. To me, I'll say hazard is a potential of harm. Anything that has a potential to cause harm. It may necessarily not cause a harm, but it has the potential to cause harm. Why danger may be an alert signifying or introducing an hazard. So I feel that's where I would put it.
Okay, so you are still saying the same thing with Mr. Dennis. Mr. Dennis said it's a characteristics. That is, hazard can be dangerous and it might not be dangerous, if I'm right. So while we're on the call, I think I observed that one of my oga joined this Zoom call, and I need to give honor to whom honor is. Honor is meant to be given to. And I welcome you, my head OHS, that is the head occupational health and safety in Ibadan Electricity Distribution Company, Alaja Miriam Arulu. You're welcome, ma. So, because she's my oga, so we are still learning from her. I know she's just here to come and see how our boy is performing. Thank you so much, ma. Thank you for joining and taking time out of your busy schedule to attend this call, ma. So as we're saying, Mr. Ejiro, can you be the last person to unmute so that we can move on because there's no time. So Mr. Ejiro Michael.
All right, thank you very much. My name is Ejiro Michael.
Okay.
I'm speaking from Dubai.
Wow.
Okay. I would say a hazard, like we all know, it's something that has the potential to cause harm. So, for example, we have a protruding nail around the working site. So, if it's not removed from that working location and someone steps on it, someone can step on it, which means that's a hazard already on its own. Now, risk, the danger, we're talking about danger, can also be seen as the consequences that would arise from the hazard. So let's say, like you're using the term electricity right now, the hazard there, we all know it's a powered line. Now, the danger would come into effect when you come in contact with that powered line. Now, what are the consequences of that? Electrocution, depending on the voltage, electrocution, and if the voltage is very high, it will lead to that. So the danger is more of the consequences that would come once you come in contact with the hazard. So the hazard is different from the danger, which means the hazard is the thing that's going to cause the injury, while the danger, or we say the consequences, is what will result out of the hazard. Thank you.
Yeah, thank you so much, Mr. Ejiro Michael, Miss Omolola, Mr. Dennis, and Mr. Opong for giving a voice to this. Virtually, I'll say every one of you, you are right and you are correct. So when we talk about hazard, so hazard is just that thing that has that potential to cause harm, while the danger is just about the characteristics. That is, hazard can be dangerous. I get and just a characteristics. So now looking at it from the instance or the example Mr. Ejiro gave, let me just quickly use this domestic example because some of us might not be able to relate with the electrical sector most immediately. Now, looking at it, if a water is being poured on the floor, now we have a slippery floor or a wet floor. So now that slippery floor or a wet floor there is what? Is an hazard. And looking at it, it has the hazard of what? Which could result to what? Slip and trip or slip and fall. You get what I'm trying to say? So now looking at it, if someone is not being exposed to it, the hazard cannot be dangerous. The hazard cannot be what? Dangerous. So in electrical sector or electricity generally that we know is an hazard on its own. It's always readily available to harm. It's readily available to harm, but the moment you are being exposed to it, that makes it what? That makes it an hazard. So in a nutshell, I just want us to know that something must be done wrong to make what? Hazard harm you. That is, if you don't do something wrong, then hazard cannot harm you. That is, you have to do something wrong, that is an unsafe act that will end up making that hazard to harm you. But if you did not commit an unsafe act, hazard cannot harm you because we, even human being ourselves, we are hazard. We human ourselves, we are hazard. So now let me move on. As time goes on, during the course of the slide, I think we'll get to know more about what an hazard is. So as I was saying, I said there is a concept of what? An accident. And for an accident to happen, I said earlier that you must be exposed to the what? To the hazard. And we all know that hazard is an agent that can what? That can cause harm or damage to human property or the environment. That is anything that has the potential to cause harm. So for an accident to happen, you must be exposed to that what? To that hazard. And how can we be exposed to this hazard? There are two ways, which we call the what? The causation of an accident. The causation of what? An accident. Looking at the causation of an accident, we have the unsafe act and the unsafe condition. Unsafe act and the unsafe condition. As we know, everything around us could be an hazard, but the moment, how are you being exposed to it? The exposure now is what we now talk about the unsafe act. So that is, you are being exposed to the hazard by committing what? An unsafe act, or you are being exposed to the hazard due to what? Unsafe condition. For instance, now, like an energized naked wire that is on a wet floor. Energized naked wire that is on a wet floor. That is an unsafe condition. So when we now talk about an unsafe act is probably when you yourself use your own naked hand to touch the what? The naked energized wire. That is an unsafe act. So looking at it, before an accident occurs, there must be an exposure to what? To hazard. And okay, so as it is, we have what we call the near miss, and we have what we call the what? The accident. Now, I said earlier that when we talk about the vulnerable person or vulnerable object, anybody who is vulnerable is what? Everybody is vulnerable. That is, anybody who is exposed to that hazard is what? Is vulnerable. And we have the near miss. That is, when we talk about the near miss, although we have incidents is divided into two, and that is the near miss and the accident. Incident is divided into two. That is the what? The near miss and the accident. So now looking at the near miss, that is, it is an unplanned event that has the potential to result to what? Injury, damage to equipment, damage to property, or even what? Loss of life. And also, when we talk about an accident, that is, it doesn't only have the potential, but it resulted to. Accident resulted to what? Resulted to injury, damage to property, or even loss of life. And looking at this hazard now in this arrow, sorry, let me use the full screen so that it will be easy for me to pick. Can we still see my screen, please?
Yes, sir. Yes, sir.
Now, look at this place I cycled. Can you see this hazard that I cycled now? Now,
Yeah, we can see
the
it.
important hazard that we are talking about, there is a barrier here. And that barrier, those are what? Probably the control measures you failed to put in place or you kept in place. Do you get what I'm trying to say? So at the long run, this vulnerable person here is someone that this person that is vulnerable has the what? Has the tendency to be harmed by this hazard. Now looking at this spear or this arrow, it is what? The hazard trying to what? Attack or harm the vulnerable person. So the first arrow here that I'm about to cycle here, can you see this arrow that I'm cycling here? Hello, can you see it?
We can see it. We can see it.
Yeah, good. Now looking at that arrow,
Yes, we
we'll
can see
end
it.
up saying that it was at a very close proximity. It was at a very close what? Proximity to attack or to harm the vulnerable person or the vulnerable object. So in another word, we can say near miss is an unplanned event that gave the room for you to go back to your church or to your mosque to give testimony that, thank God, though, I almost became a victim of what? Of an accident. But accident itself will not give you the opportunity to go back because you have to be injured. That is injury, damage of property, equipment must what? Must occur, which can even lead to what? Lead to death. There was a term Mr. Ejiro Michael used that I think I need to quickly correct. Mr. Ejiro was saying electrocution, which might lead to what? Fatality. In electrical sector, we the word electrocution is not the same thing as electric shock. An electric shock is not the same thing as electric burn. The same way when we talk about fatality. So for the sake of those people that are not safety personnel or safety officers here, whenever you hear the word a fatal accident just occurred, a fatal accident just occurred, that means fatality means what? Death. Meaning for you to have had a fatal accident just occurred means someone has died in that unplanned event. So if no one has died in that unplanned event, even though they had fracture, they have dislocation, their hand got amputated immediately on the scene due to the incident that happened, and the person is still breathing and has not been declared dead, it is not a fatal accident. It is just a major or serious accident. Let me come again. It is until when it is being declared that someone is dead in an accident scene, that is when we call it what? A fatal accident. But so far, no one is being declared dead, no matter the flow of blood, no matter the degree of injury. It is just a serious or major accident. But in the electrical sector, I know some of our safety professionals have been misusing the word. In the electrical sector, when we talk about electrocution, electrocution is just a word that has two meanings. That is, electrocution means electricity has executed the victim. Electricity has executed the victim. That is, if the victim is still very much alive and the victim is not yet dead, then the victim only receives an electric shock. The victim only receives what? An electric shock. When you say someone has been electrocuted, that is, electricity has killed the person. That is, the person is no more alive. But when we talk about electric shock, that is, electric shock
Am I the one who has left the scene, or I can't hear him again? Please, if you can hear me, kindly signify. Otherwise, I assume I'm the one who has lost network.
Can anyone hear me, please?
I think,
Can anyone
yeah.
hear me, please?
We can hear you.
Yeah, I'm hearing you.
Yeah, we can hear you now, please.
But it freezed a bit before.
Please go ahead. Please go ahead, please. Mr. Hakim, can you hear me? Okay, I think, can any other person hear me? If you can hear me, just type one instead of mute.
Yes, we can hear you. We can hear you.
We can hear.
So I think his network issue. So where he stopped from is differentiating between electric shock and electrocution.
Can you hear me, please?
Yeah, we can hear you now, please.
Now we
Yes,
can
we can
hear
hear
you.
you.
Were you able to get the definition or the difference between the electrocution and the electricity I was trying to explain?
Yes,
We get it. We get it.
Please kindly mute yourself.
We get it. We get it.
Okay. So when I talked about electrocution, then electrocution means that what? The electricity has what? Executed what? The victim. But when we now talk about electric shock, that is in a layman word, the electricity just used the person as a medium of flow. As a medium of what? As a medium of flow. That is, it just used the person to, as an electricity just flowed through the person's body. Do you get what I'm trying to say? So can I continue, please?
Please continue.
Continue,
Okay,
continue.
Good. So when we now talk about electric burn, you know, when you see someone that they pour petrol on or they use fire to burn, and you see any traces of burn as a result of the contact with electricity, that is what we call electric burn. So do you know the differences between electrocution, electric burn, and electric shock now? So whenever you hear electrocution, it means the person has died as a result of coming in contact with what? Electricity. So let me move on, please. Sorry, I don't think what's happening. So now, looking at this now, we are talking about the unsafe act and the unsafe what? Unsafe event. So, escape, sorry. Okay, so I was talking about the accident causative factors earlier, which I said we have the unsafe act and the unsafe what? Unsafe condition. So the unsafe act, that is what? The action you did that is not safe. Why the unsafe condition is the what? The condition of the environment where you are. Now, looking at this illustration in this diagram, we would see that this person are trying to lift an heavy load. Let's call this heavy load a transformer using a crane, which it is already suspended. And if you look closely, you will see at that cycled point that the, how will I use it? The lifting chain is kind of faulty. So that lifting chain that is kind of faulty is a what? Is the unsafe what? The unsafe condition there. This lifting chain here is the unsafe condition there. So, and now looking at these people on Safe Act, number one, they are not using ADAT. Likewise, they are working under a suspended heavy load, that is the suspended transformer. And that's the Unsafe Act. Now, looking forward, you would end up seeing that the near miss, according to what I defined earlier, I said it is an unplanned event that has the potential to cause harm. Now look at it. Unfortunately, this chain snapped, and when this chain snapped, the transformer that was suspended fell. And on falling, it fell at a very close proximity of where these people is, meaning that if they had moved a step ahead, probably this transformer will have fell on their head. So it is a near miss that it almost happened, and they escaped it, but they had the potential to have been harmed or trapped with this falling heavy load. But when we now talk about the accident, I said it's something that ended up resulting to what? An unplanned event that ended up resulting to what? Injury. And looking at this situation now, they are being what? They are being trapped, which end up leading to their death. So now looking at it, we have hierarchy of control. For every job we do, there's always an hazard. And how do we go about it? It's by what? Trying to identify the hazard. And after identifying the hazard, we look for the what? For the hierarchy of control that we can use to manage the hazard as low as reasonable practicable. But the best of the elimination, the hierarchy of control is the what? The elimination method. Now, using this crocodile approach that we are looking at, now the crocodile here is the hazard. That is, this crocodile has the potential to what? To cause harm. This crocodile has the potential to cause harm. And looking at it, the best thing the man thinks he can do is to what? To eliminate the what? The crocodile. For instance, if there is, how will I call it? Okay. Which other example can I use? I don't want to go into the electrical sector. Okay, let me use an electrical sector for the sake of those that are in the electrical industry. Now, we have a circuit panel. The circuit panel is always in the injection substation where we on our electricity, where we power the electricity and supply our consumers. Now, looking at the circuit panel, if it is faulty, the moment we remove completely, as in we remove the circuit panel completely from the injection substation, that is what we call the what? The elimination method. That is, we've removed it completely. That is what we call the elimination method. Now, the substitution method, which is in number 2, you would see what it did. It threw the crocodile into the waste bin and substituted it with a less harmful animal. That is a cat. Just like as we know in our house now, mostly they've started substituting a toxic or chemical-based paint with a water-based paint, so that it is what the water-based paint is more what? It's less harmful, unlike a chemical-based paint, which has lead. And research has said that lead is very what? Is very harmful. Now, when we now talk about the engineering control, looking at this person was able to what? Was able to keep the crocodile inside a what? Inside a cage. That is, it has been able to reduce the effect at which the crocodile will be able to harm him freely, assuming the crocodile wasn't in a cage. Just like in our power sector that we're talking about, part of the engineering control we use is what we know as the what? The lockout tagout. That is trying to isolate the electricity using our isolator. And also part of the engineering control we use is also using our what? Our grounding clusters to what? To redirect the flow of the current in case there is a what? There is backfeeding or induction on the power line that our workers are working on. Now, when we now talk about administrative control, part of the administrative control is what we are doing today. That is training, that is administrative control. The use of toolbar stock, that is administrative control. The use of job hazard analysis, that is administrative control. All these are things we try to do. Using of permit to work system, all those are administrative control. Then the last resort, which is always the what? The PPE, that is the personal protective equipment. And note, for the sake of those that are not safety officers here, PPE is always the what? The last resort. And sometimes PPE always fail. PPE always fail because it's the adequately using a PPE or adequately wearing a PPE. Some people would turn their other, they'll turn it to face cap. They would forget to use their what? Hello, can you still hear me, please?
Yes, yes.
We can hear you.
Yes, we can hear you better.
Yes, we can hear you.
Thank you so much. So as I was saying, I said PPE is always the what? The last resort. And this PPE can fail anytime. So looking at it,
am I the one who's lost?
It's always advisable that we should what? We should try as much as possible not to rely on our PPE and ensure we try all other hierarchy of control before the use of what? PPE. PPE is just like an additional measure in trying to prevent the wearer from direct effects of the residual hazard that we could not control during the use of the what? Elimination, substitution, engineering control, and what? Administrative control. Okay, so the next thing we are trying to talk about is what? Electricity and you. So under this electricity and you, we are going to make you understand what electricity is all about. We are going to make us understand the power sector value chain, how electricity is being generated, how it moves from the generation company to the transmission company, and now it's moved to the what? To the distribution company. Here in Nigeria, the generation company, which we know as Genco, is a private company, while the federal-owned company or the government-owned company is the transmission company of Nigeria, TCN, and the distribution company, that is the DISCO, that is also a private-owned company. We have different distribution company. We have the one of the Ibadan Electricity Distribution Company. We have the Ikeja Electricity Distribution Company, Eco Electric Distribution Company, Kaduna, Bini, Abuja, and so on and so forth. So looking at it, we are also going to talk about the electrical hazard, identify them, and see how we can control them. We're also going to talk about the OHS in the power sectors and regulation, the safety clearance from energized line, and what? Equipment. Now, what are we talking about electricity and you? As we know, in our day-to-day activity, we always come in contact with what? Electricity. This morning alone, some of us have charged our phone. This morning alone, some of us have used our hot plates to cook. This morning alone, some of us have plugged our TV, meaning we have day-to-day activity, day-to-day contact with what? Electricity. So, hello. Wow, what's happening?
You can hear, please go ahead.
Go ahead. I hear you.
We can hear you loud and clear.
Okay, I want us to watch
I can
this
barely
video.
hear. I can barely hear.
Sorry. So I want us to watch this video. Can you hear the video? Can you hear the sound of the video?
We can't hear the sound, but I think it's better to just go ahead because of the bandwidth. The length of the video, the bandwidth can affect the network. So it's better to just go ahead and pass the message across.
Okay. I know most of us must have seen this video. Now, this video is just a video of a comedy video that was done by Chris Clown, that we all know, on electrical hazard. So in this video, he went on to, there was a faulty electrical stuff in their house, and he went on to try much as possible. He went on to try as much as possible to see if he could fix it, while his father was telling him that he should try as much as possible to wait for the electrician to come. But yet he moved on and went to do this job. And at the end of everything, when he received electric shock, he left it and waited for the electrician to come. In this video, there are two things we need to learn. The first thing there is about the what? The competency. So when we're talking about the competency, most of us, we always want to feel like, because we did physics, we did chemistry, we did electrical engineering in school, due to that, we can just use our idea to move close to the electricity and start what? And start trying to make a repair, which is always very wrong. Always try as much as possible to get a competent person to carry out your tasks. And as a means of public sensitization, here in Nigeria, it's always advisable that you should always try as much as possible that anything involving electrical connection inside your home, always try as much as possible to engage LECAN. That is a licensed electrical contractor association of Nigeria, a member of LECAN. But if it is anything that is involving the power line, that is LT line, HT line, try as much as possible to always inform the distribution company close to you. If you are in Ikeja, inform those IKEDC. If you are on the island, inform those people, that's Eco Disco. If you are in Ibadan, Ogun, Osun, Kwara, inform those in what? Ibadan Electricity, Abuja Electricity, Enugu Electricity, Bini Electricity, and so on and so forth. So looking at it, also, when you are trying to involve people, ensure, and that is what I'm trying to emphasize on, you get a competent person. So what is electricity itself? Electricity is the flow of electrons around the cycle. And we have two types of electricity. We have the static electricity and the current electricity. When we talk about the static electricity, that is the electricity that gathers in one place. I could remember when we were in secondary school, during my secondary school days then, when we were being taught this static electricity, we were asked to hold a pen, that is the case of our biro, the case of our pen, and use it to rub our head, our hair. After sometimes we move it close to what? close to a piece of paper, and it was like as if it was trying to magnetize. So looking at it, electricity generally, static electricity is just trying to gather the electricity in one place, while the current electricity involves the flow of electricity from one point to what? To another. So what is a conductor? What are insulators? And what are grounding? So we have different types of conductors. And when we talk about conductor, conductor is any material that allows electricity currents to pass through it. So we have the copper, we have the aluminum, we have the steel. Any metal that can allow the flow of electric current is what we know as what? Conductor. We ourselves as a human being, we are also a very good source of conductor. That is because we have some of this. Hemoglobin, iron is in us. We have a lot of mineral resources in us, which will allow the flow what? The flow of electricity to pass through us. So we're also conductor. So when I talk about insulator, insulator is any material that does not allow electric current to pass through it. That is anything that will prevent the flow of electricity. It's what we call what? Insulator. As you know, when we get our electric cords at home, you would always see there is always a rubber-like shell at the outermost part of the wire. It is an insulator just to prevent the flow of what? Electricity to come to you when you hold it. We have different types of insulator. We have the plastic, the rubber, the glass, we have the cloth and the wood. So, and sometimes insulator can also give room to be a what? To be a conductor. That is, when the voltage is more than what the insulator can resist, then it ends up giving room for the what? For the insulator to become a conductor, which we call the breakdown voltage. The breakdown voltage. So in this point, we'll also be talking about the grounding, a conductive connection to the earth, which acts as a protective measure. Some of the grounding clusters, we can always call it an earthing system in our house. Some of us call it the GCFI, that is the ground cycled fault interrupter, which can also be used just to ensure that when there is, it's used as a protective measure to prevent the flow of what? Electricity. So looking at it, before then, I would like to quickly chip in something. I said earlier that every insulator is a what? Is a potential conductor, and its breakdown what? Its breakdown voltage. So this training is not just a training, but also a way of what? Sensitizing the public, especially we that we are safety professionals, so that we can know that before you decide on the type of PPE you need to give someone to carry out a job, you need to ensure that the PPE can serve the purpose of what it's meant to be used for. A very good instance is we have different types of electrical voltage. We have the 33 kV voltage, we have the 11 kV, we have the 0.415. And as it is, looking at it, if someone uses a rated hand glove that is meant for 11 kV voltage and using it for a 33 kV job, the person is only exposing his or herself to the danger of being electrocuted or receiving an electric shock in case the insulated hand glove, which is rated to be 11 kV, end up giving way for the 33 kV conductor and 33 kV energized electricity to pass what? To pass through it. Now, it is hard to imagine life without electricity, as electricity is everywhere in our life. Electrical power, properly contained and controlled, is the lifeblood of our world. However, we can't see, hear, taste, or smell electricity, and we tend to take it for what? For granted. As we all know, electricity generally cannot be seen, it cannot be heard, it cannot be tasted, and we cannot smell it. But note, any wire or any conductor you see, always take it as an energized conductor. Always take it as a what? As an energized what? Conductor. Until a competent person confirmed that that cable or that electrical cord does not have potential in it. Now, we've seen cases of people that they will just carry their car, they will just park under HT line. When we talk about HT line, this is how you identify HT line and LT line generally in our community. When we talk about the overhead power line, you would observe that there are some lines that they only have 3 electrical conductors on them. 3 electrical conductors. When I talk about electrical conductors, those are the lines, the aluminum conductors. It can be silicon conductors on them, which is either 11 kV or 33 kV. Why the line that comes into our street, our houses, are what? Are always 4 lines, that is 4 phase. The red phase, the yellow phase, the blue phase, and neutral. So most of us, when we are driving, for whether we are car owners, we'll just park under the wire, and guess what? Sometimes we end up falling a victim of electric shock or even electrocution, because line won't tell you when it's going to snap. When we talk about the word wire snap means when the wire will cut down on the floor. So the potential or the energized conductor, you don't know them because you cannot see them, you cannot hear them, you cannot taste them. So it is very wrong for you to park your car under a power utility line. You will see some people, their mechanic workshop is under power line. That is right of way. Going under the line and working under the line, it's very harmful, because if the wire drops, it can end up killing every life, every living organism that is under that line. We've seen cases of that in the past. There was a case of an incident that happened, I think it is Benin or Port Harcourt, I'm not very sure, whereby they were in the market. I remember Mr. Waliula also shared it in one of his safety moments video, whereby it was raining. After it stopped raining, there was an erosion and there was a wire snap. The wire dropped in one of the drainage system, and everybody who inserted their leg inside that erosion immediately got electrocuted, and several people died. Now, looking at it, working or putting your container or putting your shop or building your house under a power line is very, very wrong. As time goes on, we'll talk about that. Let's move on, please. So when we talk about the way electricity is being generated, as we all know, we know of the Egbin power line and the power plants. We know of Kanji Dam. All these people are called the generating company. What they do is to what? Is to generate the electricity either through hydro. I think solar generation is coming up soon. So looking at it, when they generate their electricity, they step it down to 330 kilovolts. When we talk about kilovolts means 1 kilovolt means 1 kilovolt means 1,000 volts. 1 kilovolt means 1,000 volts. So 330 kilovolts means 330,000 volts. That is, this 330,000 volts will now be sent to the transmission company, which should be first step down to 132 kilovolts, then further steps down to 33 kilovolts. So this 33 kilovolts is what will now be transmitted from the transmission company down to the distribution company. So when it gets to the distribution company, with our own transformer, we all know what the purpose of a transformer is used for. A transformer helps to what? Helps to step down or step up the voltage. So this 33 kilovolts that is being sent to our distribution substation or to the distribution company will now be stepped down to 11 kilovolts. So this 11 kilovolts is what will now be sent out to what we call the distribution substation, which it is commonly known as transformer. All those transformer in your street or at the points at your house, those ones are also known as what? The distribution substation. So this transformer, we have different type of transformer. We have the mounted transformer and the ground transformer. The mounted transformer, those ones are the ones they mount on the pole, while the ground transformer are the ones you see on the floor that they either use a concrete block to to prevent or use a bar wire or anyone. So from there, the electricity will be stepped down to 0.415 volts. Although we have some transformers that step down directly from 33 to 0.4152. So this 0.415 is what is now being sent to our house. We have three phases that is coming into our streets. That is the yellow phase, the red phase, the blue phase, which are 0.415 volts. But the neutral there will now help to step it down to what we eventually see as our what? 230 to 240 volts that we use in our house. So looking at it, we have different types of electrical hazard that we can identify, but these are some that I'm going to talk about. The defective insulators. So when we talk about the defective insulators, I've mentioned earlier that we have different types of insulators. And what are insulators? Insulators are any material that prevents the flow of what? Electricity, or does not allow the flow of electricity to pass through it. So now, for instance, some of us, our wires or our cables at home has been what? Are naked as a result of what? As a result of some factors due to probably rodents. Some of us, when there's no electricity, maybe rodents have spewed the wire. Some of us, it might be as a result of aging and the insulator has lived the lifespan that it was being designed to live. So at the end of everything, when this happens, it exposes the conductor, and if this conductor or this defective insulator we are talking about, you come in contact with it, it can end up leading to what? Electric shock or electrocution. So part of what we need to do is to always do periodic inspection of our cables to confirm if they are peeled. And for those who are working on construction sites, there's something we call electrical cord connector. So in this case, you use the electrical cord connector to connect this back and use your insulating tape, that black tape we know. You use it before you continue using the defective insulator. So when we talk about the overloaded circuit in this condition is when you overplug things in an extension. For instance, this happens majorly when probably there's a power outage and you have one single extension box, and inside the extension box, you put another extension box. At the end of everything, you put different types of plug upon plug upon plug upon plug. By the time you overload this circuit, there's something that would eventually happen. The circuit that you are talking about, which is the electrical cable, has a voltage or a milliamps that it has been designed for. So if the voltage that is passing through that cord is more than the milliamps it has been designed for due to overloading the circuit, it ends up resulting to a situation whereby the wire will start melting. And by the time it starts melting the insulators, maybe probably the neutral and one of the faces of the conductor end up touching each other. It can end up resulting to electrical fire. It can end up resulting to electrical fire. We have cases of this whereby people will end up leaving their what are we calling it? Their hot plates, putting it with other materials and all those sort of things. And at the end of everything, the socket outlets will end up melting and leading to electrical fire. Now, the next one is exposed electrical parts. When we talk about the exposed electrical part, most of us, we might have this in our house, probably our main switch that has a cover, and we opened it down. As it is a potential hazard. It is a potential hazard because if someone eventually end up going to it and getting to touch it, it can end up leading to what? Leading to death. So we've talked about wet condition too, whereby you leave a defective or a naked energized wire on the floor that is wet, which I gave an instance of an incident that happened in a market whereby there was an erosion or rain just finished falling and there was a wire snap which ended up electrocuting all those people who inserted their leg inside that flow of water. We have cases of overhead power lines too, overhead power lines. When we talk about overhead power line, I've mentioned it earlier. That is our poles or the lines you see that is bringing electricity to your what? To your community. Also, improper grounding. When we talk about improper grounding, this one I'll be diverting a little bit with this improper grounding. This improper grounding, we are talking about the earthing system. The earthing system. Please, can anyone still hear me?
Yes, yes,
Good. So when we talk about the ethnic system, we've had several cases of people ending up dead in the distribution sectors. For instance, now, there was an incident that happened in one of these distribution companies that I know here in Nigeria, whereby there was a power surge. So when there was a power surge, and when we talk about power surge, most of us know what they call power surge. That is the period whereby there is a high current or high voltage in your house. Sometimes it leads to the bulbs, the electrical bulbs, getting damaged. They're just hearing pow, 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 or even sometimes it even damage your TV appliances and things like that. So this electrical power surge that happened ended up resulting to the stage that someone who was about picking up something in their refrigerator ended up receiving electric shock. So from the look of things, we've seen cases of before this could happen, we would have observed that it's as a result of what? Earthing system. Some people, when you move close to your refrigerator, you touch the fridge, it shocks you. You'll be like, maybe because I did not wear rubber slippers. Some of you, when you rest on the wall after the rain just finished falling, you received an electric shock. You'll be like, maybe it's because I did not wear slippers. Some of you, you will touch your hot plate or you will touch your stabilizer at home that is working. You would receive electric shock. You say maybe because I did not wear rubber slippers. Oga, according to Frank Bell's pyramid, I understand that most of our safety officers will understand that several near misses will have happened. That is, a lot of incidents will have been giving you signal that a major accident is coming and it won't tell you. So all those periods when your refrigerator is shocking you, all those periods when your TV set or the wall is shocking you, it is passing a message to you. At this point, it is expected of you to go immediately to get an expert who can come and inspect it. If it is something that can be fixed, let them fix it. And if it is something that cannot be fixed, please dispose the refrigerator, dispose the TV set or the electrical appliances that is causing this, so that it won't end up leading to the death. And mostly this always happens as a result of what? As a result of earthing system. And this boils down to when we are building our houses, try as much as possible to always get a competent electrical contractor. Reason being because a competent electrical contractor will know the rated cable to be used. Because some people, what end up leading to electrical fire in some of us houses is because we want to boycott cost, or probably because we are trying to gain more from the customer or the clients. Those people working in the construction sector would end up going to buy underrated cables, which over time, by the time they start bringing in appliances that are more than that cable, it ends up leading to short circuiting, and from there it could lead to electrical fire. So we have cases like that. Some people, some of our customers has end up killing most of our staffs. They've end up killing most of our staffs as a result of what? Backfeeding. By the time there's a fault somewhere, and those in the distribution sector end up going out there to work. On getting to the field to work, some of you have this habit, which I think to talk about today. I think most of us who are listening to me would testify to this, that most of us, when we want to do our changeover, we have something we call changeover, which we use to change our electricity to generator, or from generator back to electricity or solar. Some people are using solar, some people are using electricity, some people are using NEPA, which by they have a changeover for it. Now, looking at it, it has turned to an attitude for most of us, especially guys or ladies, whereby they are watching, let's say a program or a television program, like Mr. Waliulai now that likes football, who is a Chelsea fan. Maybe let's assume Chelsea was playing with Arsenal. I'm just using this for example. And I'm looking at it, because of the stress of making his DSTV to reload, he had up NEPA. And the next thing when he had up NEPA, initially he was using his generator to what? To watch the football match. And at the end of everything, he just moved to his what? To his, should I call it his changeover, as it is commonly called, and just drag it straight from generator to what? To electricity. And you now be hearing some people, they'll say, Shomu, hope the TV no off, things like that. I know some of you be smiling because you are a victim of this. You are doing this. Some of us probably maybe we were on electricity or on generators, I've said earlier, you just switch it to what? To electricity. Now looking at it, the repercussion is this. Let me tell you the repercussion. The repercussion is that due to some factors that might be beyond our control, as a result of activities of rodents, as a result of activities of aging, it might have led to the what? To the terminal or the point touching each other. So during the period when you are trying to move it from electricity to power, you might even have explosion that can even kill you due to the fact that two voltage are meeting at the same point, number one. Number two, during the period when you are moving it to generator to electricity, some voltage from the electricity and from the generator might escape and go down to the power line and end up electrocuting, or let me use the word electrocuting, end up electrocuting our staffs who are working on the line. So the best method to deal with this is whenever you want to carry out any task or any job, it's always advisable that the first thing, if you're on generator and NEPA has restored the light, the first thing to do is go to that your what? Go to that your generator, switch off the generator. When you switch off the generator, you move the changeover from generator to neutral. After moving it to neutral, then you now move it to what? To NEPA. Don't be in a haste, because taking shortcut or trying to be in a haste can even cost you your life. Or if it is the other way around, probably there was electricity and all of a sudden there was energy interruption. The best thing for you to do is to first move it from NEPA to what? To neutral before you go and on your generator. When you're now done on the generator, you now move it from neutral to the gen. Is that clear, please? Is that clear, please?
Please,
Yes,
Yeah,
clear,
good.
clear.
So are you all promising me now, for those that are Chelsea fans, Arsenal fans, that those that love watching Z World, you won't go on and start doing fast switching of generator to electricity? If you are promising me that, write yes, 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 yes inside the chat box.
What of those that love PP Naija?
What?
Those that love to watch PP Naija.
Watch
Big Brother Nigeria.
Please come again. Please come again.
BB Naija. Me, I'm still a minor, so I don't know what is BB Naija. New. The last part I was trying to talk about. Can you hear me now?
Please go ahead. We can hear you, please.
Loud and clear with my ears.
Hello, can you hear me? For the person asking me to come again.
See,
Okay. What I'm trying to emphasize on is that you should try as much as possible that when you want to make use of a changeover, always try as much as. Hello, can you hear me now? I was muted earlier, sorry.
Please go ahead. Please go ahead.
Okay. So I said for the electricity that we are talking about, are we getting? When you want to do your changeover, if you were on generator before and you want to move to electricity, due to the fact that your power distribution company has restored the electricity, you first go and what? Off your generator. After you off your generator, you move your changeover from generator, you move it to what? Neutral. After moving it to neutral, then you move it to what? To the electricity. But let's assume you were on electricity before and the light was interrupted and you need to on your generator. First move the changeover to neutral. After moving it to neutral, go on your generator. After on your generator, then take it down to what? To generator. I think that is clear now. And for the one of the ethnic system or the surrounding clusters we're talking about, whenever you think you are having electric shock from your refrigerator or you are having electric shock from your wall, always call an expert to come and inspect it. Especially, always ensure you do periodic inspection of your ethnic system. Periodic inspection of your what? Ethnic system, because sometimes most of the ethnic systems that the contractors that help us do the ethnic system by are always what? Are always of a cheap or underrated standard, whereby at the end of everything, it fails, and which might eventually lead towards death if we don't quickly attend to it when it has started giving us all the symptoms of what? Electric shock. Now we have the case of frayed extension cords. We have faulty wiring. When we are talking about faulty wiring, that's the one I was talking earlier about. Under the faulty wiring that I was talking about earlier, we would see that most of us, due to the fact that we have inexperienced electrical contractor, they will just merge wires together, running wires in our house, and at the end of everything, it ends up leading to what? Hazard. Improper handling of tools is also an hazard. You will see this happens a lot in the construction sectors, whereby they would they eventually use a tool probably that doesn't have a good insulator. So we have the voltage fluctuation. That was the instance of that one I was talking about, the power surge earlier. The cable current capacity. Most times, when we talk about the cable current capacity, most of us, we end up getting an underrated cable. So always watch out for the cable we get. By the time you see any cable that is melting, please and please, if possible, get a more rated cable for you not to have the case of what? Electrical fire, or the case of what? Electrocution. Counterfeit products. Counterfeit products, this one we experience it more in the injection substation, whereby there's always a counterfeit. So don't let me go in depth inside that. So now looking at this, can anybody recognize any hazard? Using this example, can anybody recognize any hazard? If you can, just unmute yourself, introduce yourself, and please do. We have limited time, please.
Hello.
Hello, I can hear you. Please introduce yourself.
Okay, my name is Saike Daniel Ojo. I'm a safety officer in a manufacturing firm. So from what I can see so far, so I can see a ladder, and then I can see a, something that looks like a metal used to hook the top of the ladder to a metallic sheet fence at the top. So, and then I could also see a wire to passing under the ladder.
Okay. So looking at it, everything you saw is what I saw, but because of time, are you getting me? It's a really nice one for you. You really proved to me that you're a safety personnel. Now, looking at this ladder we are talking about, we would see, looking at this ladder, looking at this a scenario we are talking about, we will see that there is a ladder here, and that ladder, there is a cable that is passing underneath that ladder. So it is very wrong for you to place your ladder on an electrical cable, because you don't know if that electrical cable is in potential, and you don't know if any part of that sector that you are placing your cable on is exposed. Are you getting me? And on this note, I also want to add something. Please and please, for God's sake, we have different types of ladder. We have the aluminum ladder, we have the fiberglass ladder, we have the wooden extension ladder that we use in the electrical sector. Please and please, if you see anybody on any power line using an aluminum ladder, please and please, kindly help us stop them. It can be at Ikeja, it can be at Eko, it can be at anywhere. Kindly help us stop them, because carrying an aluminum ladder to go work there is just as if the person is going to what? Commit suicide. And sometimes when probably one of the marketers or CROs have come to your houses to disconnect your electricity, you end up getting one local electrical contractor that would now carry a ladder going to do reconnection. Oga, you are only trying as much as possible to expose this debt. We've seen cases of people whereby they would end up going on there to just go and connect, and they received electric shock, and they end up what? Becoming permanently disabled or temporarily disabled, or even leading to electrocution, which led to death. And the project of probably in your community, you guys are erecting poles. If it involves you guys erecting poles, probably because in the community you had a wooden ladder and wooden pole before, probably termites has eaten the wooden pole, and you want to change the pole, and you end up going on contributing among the community, buying a concrete pole or buying a pole that you want to re-erect, and bringing up an electrical contractor to help you do it. Please, it's very wrong. This duty is the responsibility of distribution companies. The best thing for you, even though you bought the pole, as a result that you want to fast track the erection of the pole, is always advisable you go to the nearest distribution company and tell them that you want to erect a pole. They will send their engineers down. According to NEC now, or NEMSA, it's now an offense if they see anybody who is not licensed or who is not authorized by the power distribution sectors on our line, working or trying to fix a line or trying to reconnect a light that has been disconnected. I don't know, but I tell you this, it is an offensible offense that will deal with them being sanctioned. So please be our safety advocates out there. Whether you are a safety officer or not, whenever you see it in your community, always advise them to go to the nearest distribution distribution company for them to do this. We have major things like this too on our lines, on our field, especially those in the construction sector, construction of roads. You will see trailing underground cables, and at the end of everything, you will see that this man on this yellow adart, there is a trailing cable crossing this support that they are trying to use, and the man on the electrical adart can get electrocuted if it is an electrical underground cable. So looking at it, there are several hazards we could have identified, but time is not by our side. We have cases like this too under construction sectors, whereby some people will erect scaffold, and we erect it very close to the proximity of power line. There is something we call right of way. Even at first, it's even wrong to build your building very close to a power line. Always give space for electricity. Always give space for electricity, because electricity is an invisible killer, and it can kill you anytime when you come in contact with it. So now look at this scaffold being erected very close to this. I could remember a video that was in circulation then, whereby some people were working on the scaffold, and mistakenly, I think there was a wire snap, and the wire snap touched the scaffold, which is a metallic or aluminum scaffold. And we all know aluminum is a very good conductor. Everybody on that scaffold at that moment, they received what? Electric shock. Even one of them died instantly. And in this kind of case, when there is wire snap in your area, or you see someone who died as a result of coming in contact with our power lines, please and please reach out to the nearest distribution company, so that they can help you take outage immediately and send their competent staff to come and remove the person. But in the course of you guys trying to save the person, you might eventually put yourself in more harm. Now, looking at it, we have different OHS code and this thing in the power sector. The first utility company in Nigeria was established in 1929, and that was named Nigerian Electricity Supply Company, which later turned to NEPA, which later turned to PHCN, and later became privatized under the regime of Goodluck Ebele Jonathan, which made us add IBEDC, IKEDC, EKEDC, Abuja Electricity, and so on and so forth. And we have different types of power reform, just like rules and regulations in Nigeria. So we have the NESIS code, we have the Electric Power Sector Reform Act, we have the Nigeria Electricity Health and Safety Code, which is from NEC. So these are some of the electrical safety regulations and codes that we have. I'm just trying to rush because I think I have less than 30 minutes. So looking at this, there are some that are international standard and there are some that are Nigerian standard. The OSHA 1910, 1926, these ones are what? They are international standard. The ESG 85 is an international standard. The NFPA 70E is an international standard. But the ones we use here in Nigeria, we have the Nigeria Electricity Health and Safety Standard. We have the one of the Nigeria Electricity Health and Safety Code. And we have the NESI standard, which is what? Nigerian Electricity Supply and Installation Standard Regulation. As you know, the NFPA is something most of us should know. That is the the National Fire Protection Authority. So the code 70E is talking about electrical safety in the workplace. Now, what do we call body clearance distance? So looking at this body clearance distance we are talking about, this shows the distance we need to stay off the what? Electrical conductors. So for 5 points, earlier I told you that when we talk about kilovolts, 1 kilovolt means 1,000 kilovolts. 1 kilovolt means 1,000, 1 kilovolt means 1,000 volts. Are we on the same page? Now looking at this, from 5 to 7.5 kilovolts, you need a minimum of 0.30 meters. That is body clearance, you coming close to it. For 7.5 to 12, that's 0.61, 12 to 33, 0.91, 33 to 66 kilovolts, 1.2 meters, 66 to 132 kilovolts, that's 1.5 watt meter. So we now have what we call right of way. When we're talking about right of way, I was saying something earlier when I was talking about the scaffold, your building getting close to the proximity of what? Electrical power lines. Right of way generally is just what? The distance you keep away from the structure from the what? The middle conductor. Now, let me put this on this because I need to explain this very well. So can you all see my slide?
Yes.
Now,
Yes, just continue. We can hear you loud and clear.
This is how our lines always look like. If you see a pole, now this is pole A. Can we see pole A? This is pole B. Don't mind my drawing. Are you getting this? Now looking at this pole now, there is always a line. It might be an HT line. If it is HT line, it's going to have 3 phases. What's wrong with this? Sorry, don't mind me. So it's always a 3-phase line. Don't mind my drawing, please. Just accept my drawing the way I drew it. Just an illustration. Now, this is a 3-phase line. Are we getting for the HT lines? Now, looking at these HT lines, you would see that this pole here, this pole, are we on the same page? You will take it as your radius. All of us know the point whereby when we have a cycle, we have a cycle. Now look at this center of this cycle here. The center of the cycle here. Can you see where I put my dotted points here? The center of the cycle. That is position where this where this pole is. Are we on the same page? So the right of way is for you to create a distance around, as in you have to stay away. The safe distance you need to stay away around the pole. You get? Now for 330 kilovolts, you need to take a what? The diameter is what? The diameter is 50 meters. So we're talking about diameter. Diameter is made up of 2 radius or 2 radii, sorry. Now looking at this is a diameter, 50 meters, right? From the point A, from this point A to this point B, 50 meters. So meaning for any structure you want to construct, close to 330 kilovolts, you need to be what? 25 meters away from any point close to that pole. Do we all understand what I'm trying to say?
Yes.
Hello?
Yes.
So now, for 132 kilovolts now, how many distance will you be away from this point of the pole to this
15.
point? 15, exactly. So if it is 33 kilovolts, how many distance will you be away from this point to this point?
5.5.
5.5. And for 11 kilovolts, how many distance will you be away from here to this place?
5.5 as well.
That's also 5.5. So looking at it, for any electrical cable, electrical utility poles you see, always try as much as possible. If it is 11 kV or 33 kV, please and please, your building or your structure, always stay away 5.5 meter. So that attitude of you now parking under the pole, or you selling under the pole, or you trading under the pole is very wrong, because you don't know when this wire is going to snap. And when we talk about wire snap, that's when there will be wire cut. And this can lead to what? Electrocution, which I said electricity has executed the what? The person. So in nutshell, with this, I want us to please be our safety advocates. Whenever you see anybody selling under power line, always help us advise them. Whenever you are going out, always watch under power line. There was an incident that happened to a very close friend of mine. I know he's on the call. There was one fateful day he went out on his way coming back home, because you know, a man who doesn't have pride, so he didn't wait for anybody to come and open the gate for him, because he believed he has a spare key with him. So he parked his car under a power line while he gets down from the car. And when he get down from his car, he went indoor to go and open the gate. On opening the gate, before he came out, something happened. There was a wire snap, and the wire snap fell on his car. Are we on the same page? Now, looking at it, lucky him, there was no potential on that wire. Because if there was potential on that wire, who knows what might have happened? So in a case whereby you are inside the car, or you are driving on the road and you're under a power line and there is a wire snap on your car, please and please stay inside your car and just drive the car forward for the wire to drop. Because the moment you alight from the car and your leg is touching the floor and your hand is touching the body of the car, there are chances that you will be used as a means of grounding the electricity. And meaning that if the voltage is of high voltage that your resistance cannot withstand, it might lead to electrocution. We've seen of IHAB coming in contact of a power line, 33 kV power line, and the wheel of the IHAB, the tires just busted. Pow, 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 pow. And at that point, looking at it, it shows that the IHAB has been grounded. And at that point, anybody who comes in contact of that IHAB is prone to what? Electrocution. Is prone to what? Electrocution. So looking at it, whenever you are out there, when you are talking or in a bus stop, always look up and see if there is no overhead power line on you, because you don't know when it will drop. You don't know when it's what? It will drop. So always try as much as possible to work, to do it. Now look at this person, electricity, the invisible killer. It's really unfortunate I won't be able to dwell more into firefighting. But when we talk about electrical fire generally, as we know, the source is from what? Electricity. And when we know that the source is from electricity, it's always advisable we should not use water to kill electricity. We've seen cases whereby some transformers are burning, and the next thing you'll be seeing people, get us water, get us Omo, get us water, get us Omo, and pouring water and Omo together, missing it. Oga, if you dare pour it on that transformer, and there is still residual current in that transformer, or a flow of electricity is still coming back into that transformer, it is simply what we Muslim calls inna lillahi wa inna ilayhi raji'un. That is, see, they won't even tell you, you will wake up in heaven. I get what I'm trying to say. So using water to kill electricity is very wrong. Instead, if you have cases like this in your house, it is advisable for you to what? Cut off the source of the electricity. Probably if it is something that is happening in the house, like for instance now, maybe there's an electric power voltage or power surge, and one of your colleague or one of your friend has received electric shock or is currently being electrocuted. The first thing you do is go to the power source, disengage the power source by removing the cutout of doing the changeover, if it is safe to do so. If it is safe to do so. So by the time you do that, you've what? Stopped the flow of the what? Electricity. Then with that, you can now get a wooden stick. The wooden stick is not for you to beat the person. It's for you to stylishly push the person and disengage the person from having contact with the electricity. We've seen cases of people that will use a wooden stick and start beating people, bow, bow, bow. No, you don't do that. Because at the end of everything, when you finally disengage the person, you are causing more harm to the person's body. Probably you might have breaking the person's rib. And at the end of everything, which can lead to secondary what? Injury. Aside that, we've seen cases of people receiving electric shock. And the next you say, go and bring milk, go and bring water, let him drink milk, let him drink. Okay, it is very wrong because you don't know the health status of the person. And the person might be allergic to milk and eventually what? Eventually die. So the use of milk, the use of water, the use of using stick to beat people is wrong. You only use stick, dry stick, not wet stick. Dry stick, what? To disengage the person from electricity. And also the best fire extinguisher that we can use for fighting electrical fire, they are what? DCP, that we know as the what? Dichemical powder, or CO2. CO2 or DCP. So when you're carrying out electrical work on your site, on construction site or anywhere, use more of DCP and CO2. Do not use water to fight electrical fire. Now, the next question I need to ask every one of us here is that, does low voltage, is this still the same thing as low risk? So here now, I want us to please watch this video. Can you hear the sound?
No.
Yeah?
I'm not hearing the sound.
The sound
Okay,
is
do you know what?
the sound is fine. We can go ahead with the video. The sound is okay. It's fluctuating though because of the
Okay.
bandwidth.
Thank you. Now looking at this video now, it's happened to one of this power distribution staff. While they were working, the man up here that is on yellow alert has received electric shock. It was later confirmed that this man did not die. But unfortunately, while he was being unconscious that he is up there, another staff of his was going up there to go and save him. You can see the other staff of his who is on green helmet or green alert. And on getting up there, he was trying to save the guy, but unfortunately, something happened. Watch out for that thing that happened. Do we all see what happened? Hello?
Yes. I saw what happened.
Yeah, you will see that the guy in question was trying to also save, end up receiving what? Electric shock. But unfortunately, on landing to the floor, he broke his spinal cord. He had some injuries, which led to secondary injury. And unfortunately, it's really unfortunate that he ended up losing his life as a result of that secondary injury. Now, in this kind of situation, what had happened there? Now, looking at this set of people, they've gone out there to work and they took out outage before they went there to work. So while they are out there working, unfortunately, they failed to use their grounding cluster, which is an additional means of what? Additional means of control. Sorry, I'm trying to use my ball pen. Can we see it now? Now look at this pole now. They are trying to work on this pole. So while he was trying to work on this pole, they have taken an outage on this line that they are working on. This is the line they are working on. Can we see? But while working on this line, it is a two-way thing that has happened. Immediately this happened, it's either there is an overhead line that is crossing this line they are working on. an overhead line like this. You see cases like whereby there's another line going on top of another line like this. Have you seen such before? So maybe this line here is energized and breached with this. And when it's breached with this, it sends voltage to where the man is and he became unconscious. So looking at it, that is what we call induction. But the other way around, it can be as a result of generator backfeeding. Probably when this incident happened, someone had on his or her generator in that area. And the person who owned his or her generator in that area failed to put the changeover on neutral. You know, I told you we have the neutral, the power, and the what? The generator. Now let's assume this is the generator, this is the neutral, and this is the what? The power. Now, this person has failed to put the what? The changeover on neutral before owning the generator. And during the process of pulling the changeover from here to this place to this place, some voltage escaped and went on that line to kill those staffs. Do we get that? So in nutshell, so what the question now is, does low voltage, is this still the same thing as what? As low risk? Low voltage, is it the same thing as low risk? Anyone?
No.
Why do you say no? Is it because you saw no on my slide? Can you give me the reason why you said no?
Okay, if I can say, voltage is a voltage, whether being low or being high. As far as the human, it has to do with the human body. We do not know the number of voltage that we would say it's safe for a human to come in contact with, as far as we're not NEPA staffs. So whether being low or high, a voltage is also is a high risk.
Exactly. I love that your point. May I know your name, please?
My name is Ejiro Michael.
Okay. My boss man from Dubai, right? Or Accra?
From Dubai, sir.
Okay, good. So when we talk about the low voltage generally, low voltage is not the same thing as what? Low risk. And the reason is because we have something we call letter voltage. That is the letter level of voltage. So looking at it, we would see that it depends on the resistance that the body can withstand that would end up telling us what would end up happening. Now looking at this, the extent of electrical injury can be as a result of what? The amount of current conducted through the what? Through the body of the person. Also, the parts of the current through the body and the length of time the person is being subjected to the what? To the current. That is, if someone is receiving an electric shock and the person is being disengaged almost immediately, the chances of the person dying will still be very slim. Are you getting me? Depending on the person body, internal body resistance voltage. So according to the National Institute for Occupational Safety and Health, it is stated that in dry condition, the resistance of human body can be as high as 100,000 ohms. 100,000 what? 100,000 ohms. So, and the skin may vary depending on what condition we have been exposed to. So someone who has a wet hand, the resistance of the person will not be as high as 100,000 ohms. Someone who is hypertensive or have an underlying ailment might not longer voltage. So looking at it, it's always safe to assume that any voltage you come across to is what? Is live.
Yeah.
And it can what? It can kill. Are we understand? So we talked about something which we call the what?
Mr. Mezeshinedu, you've been unmuting yourself since. Please, if you don't mute yourself now, we'll take you out of this section. Please, kindly mute yourself. You can go on, Mr. Hakim. Mr. Hakim, please go on, please. Can you hear me, Mr. Hakim? Hello? Hello? Can any other person hear me?
Yes, I can hear you, Mr.
Yes,
Yeah,
we
Mr.
can hear you.
Hakim. Mr. Hakim, we can't hear you. Are you there? I think we have lost connection with him. He will be back shortly.
I think he's muted. Just let him know that he should unmute himself.
Please.
Oh, sorry, they've unmuted. Oh, sorry, I was muted. Sorry. Sorry, I was muted. I think when he was trying to mute everyone. Can you hear me now?
Yeah.
Yes,
Can
yes, we can hear you.
Please go on,
Okay, thank you so much. Thank you. So when we talk
Please,
about
kindly
this, there
take
was
your time
something we were
too.
taught when we were in our secondary school. You remember Ohm's law. Ohm's law, which says that what V equals to what? IR. Can we remember? So now looking at this V equals to IR, that is the voltage equals current times what? Resistance. But the resistance now here we are talking about is the what? Internal body resistance. And I said earlier that the internal body resistance of a human being can be as high as 100,000 volts. But when the person is wet or is in a wet condition, it can break down the voltage to 1,000 volts. I'm sorry, 1,000 ohms. And from 1,000 ohms down and down and down like that. Are we getting it? Now looking at this, these are the voltage that when we come in contact with the leather level of voltage, when we come in contact with, and these are the effects. So for a voltage from 1 to 1 or milliamperes or less, that is 1 milliamperes downward, when you come in contact with the voltage, you just feel a sensation like something you are just feeling something moving in your palm or moving in your body or probably unnoticed. I get what I'm trying to say. So another one is from 1 to 3 milliamperes, you feel a mid sensation. During this mid sensation, that's when it's kind of obvious that you're already coming close to an electricity current. But the one of the 3 to 10 milliamperes, a painful shock, it will shock you and release you almost immediately. Whereby your body will do gree, something like that. But you yourself will know that electricity quickly passed through you. But when it is 10 to 30 milliamperes that is passing through you, this can lead to what? Muscular control could be lost. At this point, it will grab you closer. It will want to release you. And at this point, it can even lead to what we call it can lead to a situation whereby you have a burn. You have a burn. So now 30 to 75 milliamperes, respiratory paralysis. You know, as it is, everybody wants better thing. Electricity to like better thing. As electricity is, electricity knows that with the look of things, it's how will I put it? Which English will I use? Electricity knows that your blood, your heart, are we getting it? Your heart is what really pumps the hemoglobin, that is the oxygenated blood. Now, when the electricity about 70 to 75, it goes for a very good thing because it knows there are more mineral resources close to your heart. So at the end of everything, it ends up paralyzing your breathing, probably cutting off your lungs. So from 75 milliamperes to 4 amperes, it can lead to ventricular fibrillation. At this point, it can start destroying what? Your veins, your arteries. And from 40 and above, I say over 4 amperes and above, this is when your tissue will start getting burned. That's when you just start saying that the person has dried up completely, that there's no more blood in the person. So no matter what, according to what Mr. Ejiro has said earlier, there is no voltage that is not what? That is not harmful. And it's always advisable for us to always stay off electricity. Now the next slide there. So we are talking about the touch potential. Now, when we talk about the touch potential generally, that is the voltage between any 2 points of our body. That is, if you use your 2 hands to touch an energized potential, It's what? It's a touch potential. It can be shoulder to back. It can be able to this. Let's quickly watch this video to give you an idea of what the touch potential looks like. Now, looking at this video, is very common in Nigeria and some other African country or West African country. So looking at this, you would see that although according to standard, whenever a power line is being erected, I just paused the video now. Whenever a power line is being erected, according to standard, a power line cable that is being erected or a overlamp power line cable that is being erected should be based on the highest or the tallest struck in that axis. The tallest struck in that axis will determine how high the pole will be. So now looking at this now, you would see a situation where this person is going and looking at it, it touched the what? It touched the line. When it touched the line, there was not immediately completed the cycle. Do you see completed the cycle by having what? The touch potential, hand-to-hand touch potential, which made him receive what? Electric shock. And I guess he died instantly. So at this point, you would even observe that I was using a what? A hand glove. If you observe carefully in that video, you will see it was with an hand glove. And despite that hand glove, which is an insulated hand glove, it only proved to us that that insulated hand glove he held was what? Was not a rated hand glove to that voltage that is flowing. Probably is using a cotton hand glove. I don't know. And with the look of things, this is a 33 kV line or 11 kV line, which is touching, which the voltage is more than the hand glove. And by the time the voltage is more than the resistance of the body, then it gives way for what? Electric shock. Now, step and touch potential. So when we talk about step and touch potential, the step and touch potential, we've seen cases whereby all of a sudden we are standing and wire just snapped and everybody start running. Have you seen that before? So according to whenever there is a wire snap, sorry, I don't know if I could get a pen. Sorry. So whenever there is a wire snap, are we still there? You would observe that at this point where this wire drops here.
Hello, Mr. Akim.
Yes.
Please, you have 5 minutes more. Please, can you check your time?
Okay, thank you. Okay, thank you. So whenever there is a wire snap, are we on the same page? It's always advisable 10 meters around this wire where the wire drops, 10 meters around the wire, the circumference of the wire, is always advisable to stay off it. So, but in case you are in the step and touch potential zone, when this wire snaps, it's always advisable that, number one, you look at where living organisms are running towards and they are not being affected. That's the easiest way to run. Number two, you use the leaping method. Leaping method, that is, you won't spread out your leg the way this person spread out his leg. You would make your leg very close to yourself as if you are measuring monkey pose. And you'll be moving it like that till you get out of the potential zone. Or you leap. When you leap, your two legs join together and you'll be jumping, leaping till you get out of that potential zone. So in addition, maybe I should just skip this. Let me skip this. Okay. Let me skip this. So unsafe behaviors. Sorry. So let's quickly go to this common electrical injuries. So when we talk about the common electrical injuries, we have different natures of common electrical injuries. And this can be used as the acronym Be Safe. The acronym what? Be Safe. That is, the nature of injury can be as a result of what? Electrical burn, electrocution, which I mentioned earlier, that is the electricity executed the victim, shock, arc flash. Arc flash is, for instance, whereby you just suddenly hear some wires or overhead wires touching each other, and you just hearing brush, like fire, electricity sparking. So we have fire and what? Explosion. So and so on and so forth like that. So electrical injuries can result to what? Cardiac arrest. It can result to respiratory failure. It can result to muscle contraction. It can result to nerve destruction of nerve, tissue destruction, and secondary injury. So what are some myths about safety in electrical installation? Most people believe accident just happen. It's a lie. Accident does not just happen. It's not God's wish for accident to just happen. Accidents can be preventable, and research has said 99% of all accidents are preventable if we are being able to identify the hazard earlier and being able to what? Being able to put adequate control measures. So not just accidents will happen, because even according to Frank Best's pyramid, it also shows that it's different or several incidents will have happened or near misses will have happened before an incident happened. Some people said being safe takes too much time and money. Okay, the little time you would take or the additional time you would take for you to work safely is far much better than you taking a shortcut and crossing to the other side of the world. And mostly when accident happens, the cost of injury, the cost of accident, both the direct, indirect cost, compensation, medical fee, legislative fines, and all those things are much more expensive than when you take safety serious. It is impossible to achieve an accident-free workplace. Who told you that it cannot be what? It cannot be positive. It cannot be possible. It is very possible for us to what? To have an accident-free workplace. And this can only be done when we have a sustainable safety culture, a visible safety leadership, and implementing a robust risk management and teamwork would make it what? Would make it possible. So safety advice to us. Now, you should always inspect the code before issues. This is very common in construction sectors too. When you want to carry out any task, we carry out periodic inspection. So carry out periodic inspection before you carry out use any electrical appliances. Never overload a circuit. What I meant by overloading a cycle is you over plugging things in a socket. And at the end of everything, it might result to what? Short circuiting, and which can result to fire. Another one is to always stay away from unguided, that is conductors that they don't have what? They don't have guide. They don't have cover. You should always stay away from there. If you want to unplug, always pull the plug and not the cord. It's fond of us. That thing you plug inside your socket outlet, that 3-pin, that is the what? That is the plug. And stop pulling the wire. Because by the time you are pulling the wire, you're only causing damage to the insulators. Don't wear jewelry or use other metal objects around electrical equipment. Some people will wear jewelries, they wear chain, they wear ring, and at the end of everything, get close to electrical equipment. And when they receive electric shock, that metal will be the source of conductor that end up leading to that. Always de-energize the equipment. Before you work on any equipment, always what? Isolate it. Always isolate it. Always ensure that voltage has been taken off from it, or potential has been taken off from it. And we use the LOTO procedures, which is the lockout, tag out. But now we call it LOTOTO, lockout, tag out, try out. Use insulative protective equipment, that is equipment that are what? That has insulative protection. Just like that case of Chris Crown, whereby he was using a knife to lose something. Does it have the insulated protection? And is that the right tools for him to use? Maintain a safe distance from energized parts. That's the one I said earlier about the right of way and the what? The body distance clearance. Use appropriate PPE. Do not use a PPE that is not meant for the job. For instance, you want to work on 33 kV line, you are using 0.415 rated hand glove, or you are using 11 kV rated hand glove. It's very wrong to use. Use proper fuses and circuit breaker. Do not just connect conductors together and think it will serve as your fuse. Get proper fuse or ground circuit fault interrupter, GCFI. Install signages with correct safety colors. Some people will install signages that is nothing to talk about. As a safety officer, we have safety colors and code for each signages. We've seen cases whereby people will be using a red color signage for fire exit. That is very wrong. Fire exit, when you are using a red color for it, that shows you are saying it is prohibited for people to pass through that place. Fire exit is an informative signage, meaning you need to use a what? A green. When you use blue, that means it's mandatory for it to be used. The yellow is giving you warning. The red is telling you it's prohibited. Now, this video is talking about some bulls, and those bulls, they were on the field to go and take water. And at the long run, it was unfortunate that one was seeing a crocodile and the other one was seeing log of wood. He kept saying, this is a crocodile, this is a log of wood. This is a crocodile, this is a log of wood. They kept contemplating. And at the long run, the guy gave it a try and he moved further to go check if it was truly a crocodile. And by the time he moved forward, unfortunately for him, the crocodile, it was a crocodile. So looking at it, you would end up saying that don't allow people to use you as an accident statistics. Don't allow people to use you as a practical. Don't allow people to use you to test run things before they know that there is an hazard there. What you need to do is to ensure that before you begin any task, stop, think, and act. Stop, think, and act. When you stop, you ask yourself, what could go wrong? You think, have we planned effectively? Have we used the desired skills? Do I have the knowledge, the tools, the experience to carry out this work safely? Don't just jump and think because you did electrical entrepreneurship course in your school. Means you can just touch any electrical cable and start what? And start working on them. Finally, the best gifts you can give to your family is you. Please stay safe. Several people are going out there to work, and when they get out there, they hardly come back home. The only gift you can give your family is for you to come home safely and your kids sing daddy, oyoyo, mommy, oyoyo. They sing it for you when you come back home. It says only who goes to the field and come back safely is whom we say what is a safe worker. No matter your years of experience, no matter your years of expertise, immediately you get involved in an accident, then all your years of expertise or experience is a waste. So you are responsible for your safety. You are the key to your safety. So please and please, always take safety seriously. Take advantage of the protection available. Avoid carelessness, and attitude is the key. Because no matter your experience, no matter your years of experience, if your attitude towards safety is very poor, then all your years of experience is nothing but just a what? A waste. In a nutshell, some of us are working in the electrical sector. Some of us are just safety personnel. Please, I want us to be an electrical safety advocate, and let's spread this news that power is an invisible killer. Even though electricity is a good servant, but a bad master. So we must always keep electricity under our control. Stop and think before the safe way. Thank you so much, and thanks for listening to me. Even though I'm still a learner, thank you so much. And I give credit of this slide to Mr. Engineer Olaiwola Olaniyi, as he gave me these slides to use. Thank you so much. And thanks to Engineer Jami Badmos. Thanks to all my guys on the call too. Thank you. If you have any question, please feel free to ask.
All right, all right. Thank you, thank you. Please let us use the emoji of a round of applause for our trainer for today. Please kindly mute yourself. This is not the time for you to unmute. Please, we have limited time. Thank you so much. Thank you so much. Wow, this is very elaborate. This is very interesting. This is very educating and very enlightening. I'm trying to look for more words to use. It is explosive, though it's not an explosion hazard, but it is what we should be hearing at every point in time. That is why we said this training is not only limited to professionals, but even those who are not professionals. Thank you, Mr. Hakeem Mukhtar, for this detailed training. We've seen so many questions have been asked, and simultaneously we have so many of us who have answered these questions. We can see so many of our bosses, Engineer Olaiwola. You can see so many, I can't keep mentioning names, you know. We have so many people on the call, even after 2 hours. This is very interesting. Thank you, Engineer Kingsley. Thank you. In fact, I can see so many of our mamas and our papas here. Engineer Anifiok, thank you. Thank you, Ma. Thank you, sirs, for making it up to this moment. This is the end of today's training. I know some of the common questions we used to have, we used to see is that, please, can the slides be available? Will the slides be available? Yes. For every training that we do, we try as much as possible to send the material across through the mail that you send. We will share you the material and the recorded version. The recorded version will also be available. You can go to our YouTube channel to watch them later on, to use it as a reference for your own training at work. You can, and also subscribe to our YouTube channel and also invite others to our YouTube channel, where we have all these videos, all these enlightening videos, webinars, and the likes. So this training, which will be available on YouTube, is already available on YouTube now as we speak, and also the material will be sent across to us. And we will also send the materials to all the groups that we used to send our invites to. So we might also send it to our LinkedIn, but mostly through the emails. And also, please don't send out your email address. Just know that as far as you register for this training, you get the email, you get the material. And if you don't register on the groups, on all these safety groups, you will see the materials there. Please, we might not take questions because of time. I can see Mr. Peace, Miss Peace raising up her hand. Please, because of time.
Mr. Waliu, please, let's just take 2 questions, please.
Please, because of time, so many questions have been asked and they have answered the questions. Okay, please let us ask 2 questions. Please, we need to only 2 hands to be raised. Yeah, and while we wait for the question, please kindly note that again next week we're having another section. We might not have time to say this again. We might have we're having another section again with one of our safety emeritus. We also please make it a day with us. And also, we'll be having a 3-day safety training. I know most of us are aware of this 3 days technical safety training, where we'll be dealing with accident investigation and risk management techniques. We'll be talking about detailed job analysis, and we'll also be training us on HSC dashboard and safety data analysis. This 3-in-1 training is coming up next week. We have limited slots available. We have those that are registered. They are some of their members of the organization. So if you want your workforce, maybe some of your workforce to attend, also get in contact with us. And if you want us to train your workforce on these courses, they are bespoke trainings, indoor trainings, in-company trainings that we give. And we also give virtually. And if you want it physically too, we also give these trainings. So the next one will be coming up virtually on Wednesday. We have some people also that have said they want it one-on-one physical training, which we are also making arrangement for. So if you also want to participate in this training, please kindly get in contact with us. So please, Mr. Oluwatomisin, please kindly unmute yourself and ask your question. Please, briefly, please. Please, Mr. Oluwatomisin, please kindly unmute yourself.
Okay. Good evening, everyone.
Good evening.
Yes, sir. I want to ask. My question is like, just I don't know, maybe everybody maybe witness it. Like sometimes you'll be maybe working sometimes, and you just feel the shock from your elbow to on a metallic surface. It might not even be a metallic surface. It might just be on your phone. Like you might be like it happens to me. I may just hold my phone. I will just feel the shock, or just working on a surface. I'll just feel a little shock. So my question is that, like, what is the cause of that? Because the explanation you give about the 0 to 10 volts, 3 to 10 volts, then 10 to 30 volts, then 30 to 4 amperes. So I want to ask, in that relation, what is the real cause of that?
Okay, Mr. Blakim, over to you.
Based on what you said only holding your phone and you are receiving electric shock, right?
Yeah.
Yes. Holding your phone, or even like working on a metal stuff, you might just be working naturally, just feel the shock.
That your phone that you said you are holding, is it connected to power source?
No, not power source. Like for example, now it happened to me today. I went to a mall. I was paying. I want to pay for what I bought. So my hand just like touched the system, like unknowingly, like I just saw that shock, and it happens to me like that.
I would advise you go visit your doctor for medical checkup, because since you said it's not something like coming in contact with electricity, it happens to you anytime, any day. I don't think it's related to electrical voltage. So I advise you to please go visit your medical doctor for proper checkup, so as for us not to hear an unpleasant news in the nearest future. Thank you.
Final problem.
Okay. So in addition to that, it's a proof that one, you have low resistance, low body. Your conductive capacity, how will I put it, is very low. So like you said, you can meet your doctors. There are all these drugs that can improve your immune level or whatever it is. Secondly, we used to have electrical charges, electrons, that sometimes they gather and they discharge. So there are always some kind of like normal surfaces. There can be accumulation of electrons that can just discharge when you get in contact with them. So and even normally our body should be able to resist this because they are very minor, very, very minor. But when you are consistently experiencing this, it means that you really need to work on, like you said, visit a doctor. Yes. So, and like we said, we have electricity around us. We have electrons around us. They are minor. Even on like our presenter, our trainer also said, even on insulated surfaces, you can have you can have electrons gathered around it. And when they come in contact with the conductor, they tend to move. You know, they tend to move.
Hello, Mr. Waliu. I think we can't hear you anymore. Or can anybody hear me?
Yes, we can hear you, but we cannot hear the.
Yes, we can hear you.
Yeah, definitely.
Okay. So while we are waiting for Mr. Waliu to come back, Mr. Daniels, please, can you ask your question?
Okay, thank you very much. So please, I've posted my question on the chat group. Okay, so because we have workers in my facility that do plug their phones on production machine, and I just want to know if plugging of phones on machine can cause fire. And then two again, in my facility, we have three-phase machine and we have single phase like motor and some single. They will write 415 volts. So, cause from my own physics knowledge, that okay, the light that comes into the house is 220 to 240 volts. So I saw someone trying to explain it, but I do not get it on the platform. So I just want to know, how does 415, based on what you said, being converted to 220 to 240 volts, and then how does machine uses three-phase voltage? And two, also I also learned that voltage does not kill, that it is the current that kills. So that's my question.
Yeah, from what you asked, firstly, it's very wrong for you to plug your phone on electric socket at your place of work, because even in the construction site, it's very wrong to plug your phone on the socket, because even aside that, you would observe that the machine you are using, the voltage at which it is pulling it's higher than the voltage expected of the phone that you plug should be taken in, which eventually can result to phone explosion, as you've said. So you were asking another question, if why is it that 0.415 kV comes to your house, and inside the house it is 230 volts to 240 volts, right? For all those phases you are saying, we have three-phase system. The each phase you are looking at, the red phase, the yellow phase, the blue phase, each of them has 0.415 kilovolts. And there's now another phase there that we call the neutral. So the work of the neutral is the one that is at work. So for instance, I think there was an incident I remember that happened in one of the distribution company here in Nigeria, whereby in that community, they only have two-phase of electricity, two-phase of wire entering their place, and the neutral got snapped. And at that point, there's an high voltage, because the neutral is just like serving a role of trying to step down the voltage. And aside that, in our dashboard, some of us have some, what will I call it, some step down apparatus that we also have at our main circuit board. So that's about that. Which other question did you say? I think I missed the third one. Mr. Daimio?
Our advice.
Yes.
Time.
Okay.
I think the last question has been answered by engineer Efiok.
Okay.
All right. So thank you all for yourself for your presence. Like I am thinking that we will still have a second version of this section because, like we said, it's very enlightening and it is very wide. Especially when it comes to process safety, when it comes to electrical hacks, electrical discharge, the corona, the spark discharge, brush, propagating brush, all these advanced form of electrical charges and how they are generated. So I think would in the future would try to also look at these advanced areas in power, in the process safety when it comes to power distribution and electrical safety. Thank you very much, safety professional engineer, Mr. Abdulhakeem Mukhtar. Thank you everyone for being patient with us. Engineer Daniel Saiki always here with us. Mr. Michael Ejiro always here with us. Mr. Aziz, Mr. Namdi, Mr. Aminu, Mr. Abdulaziz, Mr. Ashu Muhammad, Opeyemi, Ortega, Azubike, Oba, everyone, Engineer Anafiok, Engineer Namdi. Thank you all for making it up. We can't keep mentioning names. We appreciate your presence. We appreciate your time. We appreciate you always for always being with us at every point in time. Do remember to always share our videos. Remember to always spread the news, spread the safety gospel across all platforms. Thank you all and see you all next week. Next week is going to be special just as this. And it will be more special because we're having a special trainer. I will not disclose him, and he will be training us next week, Sunday, same time, same venue. Let us be here again. Thank you and God bless you. Bye-bye.